Hi everyone. I am going to explain the chapter 7, continue the second part. Firstly, I will repeating the one and solving one question. Maybe you can remind some information. Firstly, you need to know the height of tower, but darkness obstruct the ceiling. You note that a pendulum extending from the ceiling almost touch the floor, and that its period is 12 seconds. How tall is this tower? Firstly, I am writing given. Given. Period equals it is given 12 seconds. And also gravity we know 10 meter per second square. And pi equals we are accept 3. And also we will find L. Now I wrote the two equation here. Which one is we will use? We will find L, we will using the firstly. I am writing T equals 2 pi multiply square root L over gravity. Now I am writing T equals or period equals 2 multiply 3 multiply square root L over 10. Gravity equals 10. And also T we know 12 equals 2 times 3, 6 over square root L over 10 equals 12 and 6, it is simplified 1, 2. 2 equals square root L over 10. Two sides we will, when we will multiply this square, we can inside the square root it will be moving the outside. 2 multiply 2 4 equals square root and square it will be simplify L L over 10 cross multiplication L equals 10 multiply 4 equals 40 meter. 40 meter it is approximately because of we are accept gravity 10 is normally 9.8 and also pi 3.12 we are accept 3 approximately 40 meter. Damping simple harmonic motion. Which move is simple harmonic movement? Its movement continue as long as the energy of system is reversed. But when an approximative force exists as a friction force, such as when a weight is suspended with a spring is immersed in water or high viscosity fluid. For example, look at the figures. This movement doesn't continue its vibration gradual dimensions. This type of vibration is called damping vibration. For example, pump. They are using it for industry or for lifty car or look like hydraulic. Damping vibration also has practical application benefit in the vehicle shock absorb system or suspension. For example, suspension systems. The shock absorb dampened the vibration caused by the vehicles passing on the road bumps. This one it will be look like spring. Pulls in a string. If end of the string is the set tightly and the type of the other and move very quickly, the top of or bottom at disturbance will be great generate which is called pulse. And these pulse move all the part of the stride carrying the energy. This energy is potential and kinetic energy. Without the passage of the string molecules with it, the pulse move throughout the string with the velocity, cutting displacement x. If you remember this equation, x equals, or displacement equals velocity multiply time. When the string vibrate, each particle vibrate as simple harmonic motion up and down. The maximum displacement of particle from the position of stability is called amplitude. Amplitude, the keyword. Generated in the string is a series of pulses. The speed of the wave in the stride depends on the tension of the string T and the mass of the length unit of the string, or we can showing that the symbol is linear mass density. T, it is tension in the string. This mu is the linear mass density, which is measured by kilogram over meter. We are using the equations. Linear mass density equals m means, do you remember? Mass, L meaning length, kilogram and meter. Wave speed tension in the string over linear mass density, or using speed equals square root the tension in stride over linear mass density, or using another type of similar equation, speed equals square root tension stride over m over L. The distance between the two consecutive peaks or bottom is the equal to the length of complete wave and the time of the one cycle of the wave is the time required to vibrate any point its path of the wave shake on the cycle, and the frequency. Frequency is, look at this. These different kind of frequencies. Or if you remember these equations, frequency equals 1 over period, and if you remind 8th grade you learn wave speed equals wavelength over time. Example: a guitar string with a mass of 20 grams and a length of 60 centimeters. What is the amount of the tension required in string to be the wave speed of 30 meters per second? It is given a mass 20 grams and wave speed 30 meters per second, and L equals 60 centimeters, and they are asking T, or period. Now I will use equation speed equals square root tension stride over mass over L, or V equals square root T multiply L over M. But we will find the tension stride. I am writing tension stride equals V square multiply mass over L. Now I am writing the numbers. But be careful, we must change kilogram to gram to kilogram, centimeter to meter. Now I am writing 0.02 kilogram multiply 30 square 30 square over L is 60 centimeter 60 centimeter equals 0.6 meter 0.6 meter. 10 since right equals 30 Newton. Periodic waves. Periodic waves are waves that repeat themselves at regular intervals and all type of the period. Waves have as from the sinus wave form. So this is represented by the sine curve or cosine curve, like water wave and light wave. And you remind speed equals frequency multiply wavelength, or speed equals wavelength over period. Example: a radar sends radio waves at the time of 0.08 second. 0.08 second, it is period, and frequency, it is writing 9400 megahertz. Carefully, mega meaning 10 power 9 or 9 power 6 hertz. If you know that the speed of radio waves is light speed equals 3 multiplied 10 power 8 meter per second. Find the wavelength, find the number of wave. Firstly, I am writing equation. Wavelength equals speed of and frequency equals speed 3 multiply 10 power 8 over frequency 9.4 multiply 10 power 9 hertz. This one is meter per second. Equals wavelength equals 3.419 multiply 10 power minus 2 centimeter. A 3.90 multiply 10 power negative 2 centimeter. And second number of waves. If you remember, number of waves equals frequency multiply time. Also period look like it is time. I am writing frequency, we know 9.4 multiply 10 power 9 multiply time is 8 or 8 multiply 10 minus 2 seconds equals and 75 multiply points and multiply 10 power 7. This is number of waves. Kind of waves. If you remember, you learned the 8th grade. We have the two kind of wave. One of them is transfer waves. Another one is longitudinal waves. Transfer waves, the waves in the one side tensile loop and the molted pulse where the medium particle vibrate in vertical direction on the wave propagation line. Look like a wave such as this, in the which the particle of this distributed medium move perpendicularly to the wave motion is called transverse waves. The shape is look like zigzag. Wave measuring include the crest, trough, amplitude and wave. These four of them is the part of transverse waves. Firstly, between the two crest means the top of or maximum point of the transfer wave. Top opposite meaning the crest. The minimum point of wavelength is called top. And amplitude starting point to the highest or lowest point is called amplitude. Between the two amplitude is called wavelength. Questions. The graph below represents the displacement of particle in a wave with time. If the wave is propagation with the speed of 50 centimeter per second, find this. First, the amplitude. If you look at this figure, we will not using any equation for A, B, C. And look at this figure. They are asking amplitude. If you remember, amplitude starting point to maximum point or starting point to minimum point. Look at this. Look at this. Maximum point and minimum point equals 4. Amplitude equals 4 centimeter. Wavelength. Wavelength between the two crests or between the two top. We don't know second top, but we know two crests. This wavelength. Look at this 1 and 1, and also 0.2, 0.1, 0.1, 0.2 equals totally 0.4 centimeter. B. And C, the period start when they are repeating the same wave. Look at this, starting and moving it down and finish and continue the same. Look at this. After this part it is repeating 0 to this point. It is giving the period equals 0.4 centimeter, and frequency only we will use the one equation. If you remember, period equals 1 over frequency. We find period or frequency equals 1 over period. Frequency equals 1 over 0.4. 1 over 4 over 10 equals 10 over 4 equals 2.5 centimeter. It is unit centimeter? No. Frequency is hertz. Longitudinal wave. Longitudinal wave can be represented by drawing by close straight line. Represent the compressor region and the other associated represent the rated region, or it can be represented graphical by sine curve, and it's called the compressed and rated curve of the longitudinal. Look at the figure. Vibration of the longitudinal wave parallel to the wave motion. Look at this, compressed, it is less frequency but stretch, more frequency stretch is less frequency but more wavelength, small wavelength. Wavelength, wave speed equals frequency time wavelength. Our equation, speed of the wave equals frequency multiplied wavelength. Also,